This video is on percentiles, quartiles, and boxplots. A percentile is a measure that indicates the value below which a percentage of observations in the group of observations falls. So percentiles divide the data values into hundredths. For example, a data value x is in the 80th percentile if 80% of the data values are less than or equal to x, and 20% of the data values are the same or greater. So 80th percentile means 80% of the data values are below or equal to that value. Some examples you might be familiar with would be your height or growth chart growing up. So, whenever you visit the doctor as a kid, when you're growing, the doctor might say, oh, you're in the 70th percentile for your height. That means you're, taller than average, you're taller than 70% of other kids, and so on. You might also see percentiles in placement on an exam. Just another sort of random example, the 85th percentile speed of traffic on a road is usually used to set speed limits or assess whether a speed limit is like a good speed limit for that road. In general, whether a small or large percentile is good or bad will depend on context. So why don't you try to interpret percentile in these two examples, and then we'll talk about them together in a moment. Of course, in both cases, it might depend on what Zoya and Aaron were expecting or hoping for, but we'll go with whatever seems to be most accurate or most likely. So first example, Zoya is training for the 100-meter dash in her high school track team. She finds out that her average time in today's practice was in the 5th percentile, compared with other track students in her area. Is it more likely that she'll be happy or disappointed with this speed? And in the second example, Aaron is applying to law school and found out that he got in the 12th percentile on his LSAT. That's a law school entrance exam. So do you think he'll be happy about this or not so happy? Is this cause for celebration, or should he study and take the exam again? So pause and try each of those out. We'll talk about them in just a moment. And just to clarify, the data value we're talking about in the first example is the average time that Zoya had on her 100-meter dashes for practice that day, in context of the data set of all other people's average times on 100-meter dashes or times on 100-meter dashes for other track students in her area. So it's that actual data set, and she's in the 5th percentile in that data set. Okay, so should Zoya be happy or disappointed? So her average time in the 100th meter dash is in the 5th percentile. What does that mean? That means that the actual time she took to run this 100-meter dash was smaller than 95% of everyone else's, and was longer than 5% of everyone else's. So her time was longer than 5%, or longer or same as 5% of other runners, and it was shorter or same as 95% of other runners. So whether Zoya's happy or disappointed might depend on how good she is normally. But for me, if I was faster than 95% of other people and I was a little slower than 5% of other people, I would be very happy. I would be really impressed with myself, because that's just not how things are right now for me. So I would think that Zoya should be happy. I would think that this is a good score for most people, because it's sort of better, it's running more quickly than 95% of others. In our second example, Aaron is applying to law school and found out that he got in the 12th percentile on his LSAT. Is this cause for celebration, or should he study to take the exam again? Again, it might depend on what Aaron was expecting, but 12th percentile in this case means that his score was higher or same as, or same compared with 12% of other exam takers, and it was lower than the remaining 88%. So I would think that Aaron is probably disappointed. He probably needs to take the exam again. So he should probably study and take the exam again because his score was lower than 88% of other people taking this exam. Okay, so percentiles break up the data into hundredths. Quartiles break up the data into fourths, or 4 equally sized groups. So the first quartile is also labeled Q1 or Q sub 1, and it's the same thing as the 25th percentile. So it has 25% of the data at or below that value and 70% of the data at or above that value. The second quartile, or Q2, is also the 50th percentile. So it has 50% of the data at or above it, 50% of the data at or below it, and that means it's also the same thing as the median. And the third quartile, or Q3, is the 75th percentile, and so Q3 has 75% of the data at or below it and 25% of the data at or above it. And a five number summary is the minimum data value, Q1, Q2 or the median, Q3, and the max data value. So those 5 numbers make up the 5-number summary for a set of data. And it gives you kind of an idea of how the data is spread out relative to itself. And again, it's breaking up that data into 4 equally sized groups. So you've got your min and your Q1, your Q2. Now my groups are not equally sized. Your Q3 and your Q4, or your max. And we've got 25% of the data here, 25% of the data is in here, 25% of the data is in here, and 25% of the data is in there. So a quarter of the data is between each of those sets of values. So as we said, Q2 is the same thing as the median. So to find Q2, we can do what we did last week or so and find the median. We arrange the data values in order and then find the middle value. If there's an odd number of data values, there's just one middle value. If there's an even number, we take the average of the 2 middle data values. And then to find Q1 and Q3, we can essentially just find the median again for the lower half of the data and the upper half of the data. So to find Q1, the first quartile or the 25th percentile, we find the median of the lower half of the data below Q2. And to find Q3, we find the median of the upper half of the data above Q2. We'll do some examples with this, but first I just want to say that a box plot is a visual representation of the 5-number summary. So a line is drawn between the minimum value and the maximum value, and then a box is drawn from Q1 to Q3, wherever those are. So Q1 to Q3, there's a box drawn around there. And then a line is drawn at Q2, at the median, wherever Q2 is. And of course, this is on a scale where you will have numbers associated with each of those values. And we'll do an example next, finding the 5-number summary and sketching a box plot. Okay, so we're going to find the 5-number summary for the following data values and then draw a box plot to visualize the 5-number summary. So here we have 12 data values if you count them up, and because that's an even number of values, that we know that the median is going to be the average of the middle two. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Okay, we've got 6 data values on either side. So that tells us that the median, or Q2, the median, which is the same thing as Q2, is equal to the average of the two middle data values. 11 plus 12 over 2 is equal to 5.5 is Q2. Next, we can find the Q1, and for this we are going to take the median of these 6 data values. So we're going to, for Q1, find the median of those 6 values. Again, we're dividing the data set in half and taking the average of those 2 values. In this case, it's the average of 5 and 5, which we don't really need to calculate. We just know that that is 5. Last thing that we actually have to calculate here, we can find Q3. So Q3, we're finding the median of those data values. So Q3 is the median of the middle two, the average of the middle 2 data values, 15 and 16. So 15 plus 16 divided by 2 is equal to 15.5. So we've now found Q1, Q2, and Q3. And so our 5-number summary is the minimum data value, and the minimum data value is 2, the Q1, which is 5, Q2, which is 5, Q2 is 11.5. So there was a, whoops. And Q3 is 15.5. Okay, so that is our 5-number, and then we also have the largest data value, the max, and that's 19. So this is our min, our Q1, our Q2, our Q3, and our max. And the 5-number summary should always be ordered, so it should be ordered in that order, from smallest to largest: min, Q1, Q2, Q3, and max. Okay, let's now draw a box plot based on that 5-number summary. So we see that the data values go from 2 to 19. So we have different options for how we scale our set. But we could, for example, go up to 20 and add some midpoints, maybe at 5 and 10 and 15. So we want to, this is just a rough sketch. Now we want to put in our minimum, and our minimum is at 2. So our minimum is at 2, and our maximum is at 19. So that's our maximum and our minimum. And now we draw a line between the maximum and the minimum value. There we go. And now we draw a box from Q1, which is at 5, to Q2, which is at 15.5. So there is our box between Q1 and Q3. And finally, we have Q2, the median happens at 11.5, so about there. And so remember that what this box plot is saying is that we've got 25% of our data in that region, 25% of our data in that region, 25% of our data falls within that region, and 25% of our data falls within that region. Okay, here's another example for you to try, and then we'll talk about it together. So find the 5-number summary for the following data values: 2, 6, 10, 12, 12, 13, 14, 15, 19, 21, and 27. Then draw a box plot to visualize this 5-number summary, and additionally answer the question, between which 2 quartiles or data values is the data most tightly packed? So whereas the data, like the least spread out, is the most densely packed, between which either quartiles or data values. Okay, so here we have 11 data values if we count them up, and so when we find the median, there's just one number in the middle. It's going to be the sixth data value, 1, 2, 3, 4, 5, 6. That's our data value in the middle, and it's going to have 5 data values on either side, 1, 2, 3, 4, 5. Great. So that is the median, which is also the same thing as Q2. The median for Q2 is equal to 13. Now when we want to find Q1, we are going to find the median of just the values below that. So we're finding the median of these values. And again, there's just 5 data values, an odd number of data values. So Q1 in this case is 10. We don't have to take an average. And for finding Q3, we're taking the median of these 5 data values. Again, there's just one data value in the middle, so Q3 is equal to 19. And of course, we know what our minimum is and we know what our maximum is. So now we've got our 5-number summary. Our 5-number summary is the minimum to the Q1, which is 10, Q2, or the median, which is 13, Q3, which is 19, and the maximum data value, which is 27. So now let's draw a box plot based on that 5-number summary. So we see that our minimum is at 2, and that's the beginning of the box plot, and our maximum is at 27, and that's the end of the box plot. We draw a line between the minimum and maximum value. And then our Q1 is at 10, and our Q3 is at 19. So we draw a box between Q1 and Q3. And finally, we draw at 13, we draw where the median is. So the median is at 13. And then we had the question, where is the data most tightly packed between which 2 quartiles? So remember that we've got 25% of our data is within this region, 25% is within this little region, 25% is within this region, and 25% is within this region. So each of those have an equivalent number of data values. And so we see that this is the most tightly packed, or most tightly packed region between 10 and 13, or between Q1 and Q2, or between 10 and 13. And if we look back up at the data, we will observe that that seems correct, that we've got a bunch of data all very close together right here between 10 and 13, and then it's a little more spread out down this way and a little more spread out up here as well. There's more distance between the data values in the other quartiles.